Our next speaker is Matthew. He will speak about cyber necromancy, reverse engineering dead protocols. So let's give a hand of applause for him.
All right, so as was already mentioned, I'm doing talk on reverse engineering dead protocols. It's a quick introduction. My name is Matthew Haltschak out of Saskatchewan, Canada, and if you have any idea where that is. And I'm a security technician for security innovation, just doing app level pen tests, things of that nature. Just as we get started, I do want to make a couple warnings here. This isn't a development talk. I'm not going to talk about the programming aspect of building a video game server. It's not about exploitation. It's just kind of a cool project that I was working on for a year and a half or so. So what is it? The basic idea is back when I was around 16, 17, I used to play this one online video game called Metal Gear Online. And that got shut down after about a year of uptime, and there's another version of the game released a couple years after that, which was also shut down. So this whole project has basically just been trying to rebuild that server after the server was already shut down. So unlike trying to build a private server, which is somewhat common, I was kind of left there with no packet captures, no real things to help me actually build this server. I just kind of had to look at the client and figure out what I can do. So there are the obvious problems. I mean, servers are down, no packet captures, just mentioned that. It's a console game, so I'm kind of left without any debugging functionality. I'm left without really any of the things that make making private servers easy. So just at a kind of a high level, I mean, the basic problems here are one, to redirect traffic to your server. So your first issue, I mean, if you've got a server, it's going to try and connect to the original server, which was run by the publisher. Your next issue is going to be just implementing those known protocols, if there are any. If it's using all custom protocols, obviously you're not going to luck out on this. In our case, we just had HTTP and Stun being the two that were actually used, in addition to their own custom game protocol. So traffic redirection, this is a common problem. I mean, if you're doing pen testing and stuff, sometimes you need to do this. It's a lot of different ways. One of the common things is just to patch out. Just kind of rewrite addresses that are in the binaries, rewrite anything in there. But on a console, I mean, you're kind of left with, if I were to rewrite part of the game, how am I going to distribute that to anybody to play? I could patch it out that way, but nobody's going to be able to play that game with me. So the other option is, buying the domains. In our case, it's still owned. I mean, you could try and do a hostile takeover, but there's kind of the legal questions with that. So the normal solution, if you can patch, is using a custom DNS server. So just setting up your own server to respond to that, and you can point whatever console you've got, whatever system you're using, to use that server, and it'll resolve down to your domain. I am going to be skipping over kind of a few details here, so if you guys do have questions, you can kind of ask for more information after the talk's actually complete. But one of the first problems I ended up running into was the Sony Dynamic Network Authentication System. If you're not familiar with this, basically what it is that Sony on the PS2 wanted to make sure people weren't cheating when they went online, make sure they weren't like burning copies of the game and piracy. So that's basically what this was meant to prevent. So from that, I mean, bypassing this for piracy, obviously everybody wanted to pirate games on the PS2, so you had mod chips, you had, eventually people did actually figure out a bypass for that, but what this thing also did was act as a gateway when you tried to connect to the game. If you tried to connect to the DNAS, it would go and be like, hey, is this game still online, or is there some reason why this person can't connect? So right at that point, Sony's now telling us we don't even try and connect to the actual game server. Sony's just being like, nope, this game's offline. You can't go any further. I mean, patching it, nothing's going to help. It's offline, so it would block you right there. So what I wanted to do was implement this peer server, just basically have where someone can take their game disc, if they bought the original game, pop it in the console, and be able to play again. So to do that, I'd have to kind of break this network authentication system. And in trying to do that, a couple things that were helpful here, and I'm going to be mentioning things that are helpful for my specific context, but similar concepts or similar principles will apply if you try and do this with anything else. What we did find was the Sony SDK and documentation for the actual DNAS system was really helpful, but I still failed. I never actually managed to recreate this DNAS server, so I'm starting off with a failure here. I spent quite a while working on this. The main issue is actually just trying to deal with HTTPS and server pinning and some of the issues there. But what I did manage to do was find this little string just sitting there in the binary called new DNAS connect. Follow that along a little bit, getting a little bit of reverse engineering there, and it leads you to this little function that I have to wonder, what happens if you just return 0 from it? What they ended up giving me was a bypass to the system. It would pop up DNAS, and then it would just disappear as though I was successful. But I already mentioned the issue with trying to distribute this. If you're left with patching this game, I mean, this is a PS2 game. I'm not going to press my own disk. The binaries were patched, so we can't just give out like the else for people to use. But we came across one solution here, are cheat devices. I don't know how many of you have played like with a Game Genie on the like NES or Game Shark, Codebreaker, anything like that. But these little cheat devices actually do an interesting little bit of memory editing. At least when I was growing up, these things were just kind of magic. I'd see these letters, numbers, and I have no idea what it means. But what it actually is, it's basically just allowing you to overwrite aspects of memory. So this is kind of our solution patch. And we couldn't do like a big patch. We couldn't change characters. We couldn't add a new map into the game. But we could overwrite about 4 bytes of memory at any point. So, I mean, if you keep it reasonable, I mean, there's just a few lines of code that basically does a return 0. So taking a look at that, I mean, it's the first character just represents the type of cheat. So the C is like a conditional check looking for memory at the address A. Is it equal to B? If so, run the rest of these codes. And the 2 just tells it, this is an overwrite memory at A with B. Fairly straightforward. I thought that was kind of interesting because I had no experience with this before I started working on this project. The next issue, at this point now, we're able to start connecting and get through the known protocols. I mentioned HTTP already and stun. In our case, that's pretty easy to deal with. All you need to do is set up a stun server. It's a known protocol, set up a website, serving all the right pages. It was requesting like a policy text file, so it's not too hard to figure out at that point. You can just set them right up. But what did get difficult is once we had that part, it's now trying to connect to the game server. This had its own custom protocol, its own kind of built-in stuff there. And with this, I've mentioned it already, but we didn't really have packets, but if you can get them, they help a lot. What ended up happening a little way into this project, we had someone supply us with a minimal packet capture. It had like connecting to the server and listing games. It didn't have creating games, didn't have joining a game. Didn't have a lot of useful stuff, but it did let us take a look at a few copies or a few packets. So this is kind of one, or I guess 4 examples of packets that we got in. I'm not sure how many of you, read hex fluently and just look at this and see exactly what's going on. But I mean, if you can't figure it out from the bytes, perhaps just looking at the ASCII would help. Again, I mean, if you're really kind of on top of things, you might see what's going on here, but what I'm kind of left with and what I spent a lot of time looking at this with is, I see a few repeating characters in there, but not a whole lot. I mean, Z, P. But as you start looking at looking at the actual hex data in there, you'll see the ZP still there. But you'll start noticing other characters pop up beside it also, the AF, and things like that. So you're basically left with this situation. There are no null bytes, and you see these repeating 4 bytes a lot. If you've seen this before, you probably already realize exactly what's going on. But if you haven't seen this before, you can get stuck on this for, at least in my situation, a little while. It's basically just XORing this with 4 bytes. That was their, we'll call it encryption on the packets to make it a little bit more difficult to modify. So you XOR it and you start seeing actual data there, and this should hopefully make a little bit more sense. But no, we have to start figuring out what the actual protocol is in there. These are just some of the packets. You start noticing a few things might stand out as you look at them in this way. You might notice that this one part there just starts counting up, 1, 2, 3. I think it hits 5 at some point in this loop, yeah. So, you can make a guess that that's probably some type of sequence counter. The next one that comes up is, this one's often 0, but as the size of the entire packet goes up, so does this number. So can't really confirm at this point, but you can kind of make the educated guess. Maybe this is some type of length. The first one here, we just had to kind of plainly guess at this and guess that's maybe a command type identifier. Every command would always have, when you make the same command, it would always have the same 2 digits there. So, educated guess tells us maybe that's the command identifier. And then the payload, I've already made brief mentions. This got larger, the size went up. But there is this set of bytes in here where, these are basically random. When I run into random numbers, my first thought is almost always, are these prime numbers? They're not, but that's always my thought. And it's actually worked out a few instances, but in this case, if we just take a look at those, maybe this looks a little bit familiar to some of you. They're just MD5s of the header and the payload. When you kind of take them out of the packets and start looking at how they're always the same setup there, it becomes a little bit more obvious. One difference between the 2 games, I mentioned that there's the first Metal Gear Online and a second one that was released. The second one did a little bit different hashing, but otherwise everything was the same. It used basically a secret key to salt the MD5 as it came through. So it was pretty similar, but not quite. So now at this point, we've kind of come up with the protocol being an 8-byte header, command identifier, payload length, and sequence, followed by the hash, and finally the payload. Payload's really kind of the big thing they need to worry about. What is the actual content? What's the server trying to do? What's actually going on here? And what are you supposed to reply with? You can set up a server, you can know the protocol, but if you can't reply with the right data, if you can't reply in the right format, you're not really going to get anywhere. So again, the ideal way is if you have these packet captures, you can just look at it, replay them, experiment with it. And it's just a matter of determining that transformation. So as an easy example here, we've already pointed out the sequence numbers. One of the interesting things that started popping as you looked at more of these responses was that the server's response was usually +1 of the game's request. So you see the request comes in, there's 0x2001. So the response was 2002 and 2003. So looking at the actual packets a little bit here, the payloads now. This is the XOR payload that we saw a little bit earlier, which listed the lobbies. Looking at this, you can probably make out the text there on the left is probably the name, the IP, and CDEF happen to be the ports. But you've got these dots in there, which I'm showing the bytes there. One set of them is basically 0 through 4. Again, kind of looking at this stuff, educate guess. Hey, this is probably a ID, unique ID, or the ordering of them. Next one comes up, 0, 1, and then 3 2s. Having played the game, I recognize that the Snake, Liquid, and the League lobbies are the ones that you actually see. As players, you never saw the gate and account stuff. So I'd make a guess here again that this is now typed. Then look at the other one here, 1, 2, and then ABC. It's missing some lobbies in there, missing some values in there, but again, I'm not exactly sure what was being done here, but I'm guessing it was globally unique since the servers were different for Japan, for North America, and for Europe. So I'm assuming that Japan had basically spaces between 2 and 8. So I've made a bunch of, or I guess in the other one here is I knew that Snake was always played. Most people didn't join the other lobbies. So that 90 is maybe a player count. So no, I've made a few guesses here that I'm maybe not 100% confident in, but there's still guesses there, and so start experimenting. Change the visible names, put in my own IP, and start tossing in some other information there. And of course, that ended up working. I was able to play around and figure out all the data. This is the easy way. I mean, had a packet, had everything there, everything was nice and easy. The harder way, of course, is when you don't have a packet capture. One of the things you can do, just kind of some guesswork here, is are there any commonalities that you can start to see? You know, is the payload normally XML, JSON SOAP, or is there crypto being used? If you get a copy of the slides there, this link is probably one of the best write-ups on determining what type crypto is being used from just kind of in like a binary where you don't have any extra debugging information, you don't have anything to really help you, just detecting what algorithm's being used. So a few things from experimentation that we figured out. I normally show a few examples of this, but due to time, I'll leave that out. But the first 4 bytes were generally a result or a result code. You'd have 0 in there normally being success. If you send like a 1, it would show you an error back out being like, hey, here's an error, random number, followed by whatever your response code was. And the interesting thing with that is we realized that it would only show an error if you had the right command identifier. So in cases where the command identifier wasn't that +1 that I mentioned earlier, you would be able to go ahead and just kind of loop through a bunch of command identifiers and see which one actually gives you an error, and you figured out what to do from there. So I mean, at this point, it's come down to a lot of guesswork. Some of the guesses that we found useful were sending in blanks, just absolutely nothing, just sending basically an acknowledgement that, hey, we got it back from you, leave it at that. The other thing, we're sending nulls, sending 0, this worked on the HTTP stuff, sending the success for everything, it works, but you're not really doing anything. It's like the user says, I want to create a game. You can send them the success code, but they're not actually having a game created, or they're not saving their stats, things like that. So just looking at the experimentation a little bit, we started playing around with trying to figure out items. There's just these few bytes here. And as we just played around with sending out different values in there, in this case, we just incremented that red half. You know, sent it 1, then we changed the blue part, and we started seeing more colors coming out. Incremented more, you see more colors. This is just kind of figuring out items in the game so you can dress up your characters in a sense. Playing around with the numbers, you basically just start discovering things coming up there. And we came across this mask. It wasn't actually in the game. Nobody saw this while we were playing, but it was still kind of in there. It's this Japanese wrestler, possibly in there from development, not really sure why. But we also realized that this game had downloadable content. I mean, you pay them, you get your content, and you unlock extra features. I mean, a lot of games do this. Except everything that was in those content packs were already in version 1 of this game. All you were doing was paying to basically switch a flag that told it, hey, you've got this item now. So they obviously planned every one of their release points on that. But I mean, that's just slow, it's tedious, but it's not all that difficult. Things get a little bit more complicated as you start looking at packets where you don't have, or where you don't have the packets where it's not easily guessable. So in this case, there's nothing similar either. I'll talk a little bit about that, but joining a game, obviously, if we're trying to have a game server, we want to play the game. It's no fun if I can just create a game, run around on my own, but nobody can actually join it. So the first step is, I'll just point out, there are the 3 menu items there: join game, host info, player info. This is on like the game listing. So the first step when you try and join the game is it sent this 4113 request. This happened to correspond with the game data, which we saw in that other menu, the host information. So I mean, it sends this information. We can then use that host information, start doing the replay experimentation, figure out what to send. The next one was player stats. Again, If you went through the player listing and then you select a certain player, it would send this request. So we knew exactly what it was asking for. We can start playing around trying to figure out the actual payload. The problem with this one is we never actually figured out what the payload should be. We didn't have any examples of what it should be. So we're left kind of doing a little bit of static analysis. And I mentioned the ELF is packed, and there's no debugging functionality. I can't just run the game and have it dump the ELF after it's been unpacked. So in our case, I end up relying upon a emulator. I boot the game up in this emulator all slow and 5 frames a second, get to where I want, and then make a save state in the emulator, which would give us a rough idea of what the game's memory looked like. So that was something that we found useful. But even when you have that dump, you've still got to find the code path. You've got to find that you've got to find the assembly of your code, of what you actually want to see. So in our case, we looked for nearby strings. In this case, there were no strings. I mean, this is all just numbers going by, so we're looking for numbers. 4103 came up a lot in there and wasn't too helpful. But the XOR code, we found that in memory, found where it was a reference, and then started following all the assembly going through and came across a area where we found all of these magic numbers, all of these command identifiers being checked, and then it would branch if they're equal or not equal. Likely, a switch statement in here. I mean, you'll see at the end there, it ends up doing a jump into the one function, and you can start working out what to do from there. So again, you've got JAL branch if v0, the response code is equal to 0, and it does this a lot. So at this point, you kind of have two options. You can either figure out where the check fails, which one of those 15, 20 checks actually fail, or you can just NOP using those cheat codes that we mentioned earlier. You can just kind of put a NOP in there, return 0, and hopefully that'll work. And that's what we ended up doing with this one. We couldn't figure out exactly how to make the data fit in for player stats. We just had to patch it. I'm still kind of working on this packet because I hate leaving this unfinished. But, I mean, we wanted to play the game, so just had to move forward. So from that, we've got game information, player information, host stats, which is the player stats they're requesting. And now it's sending another packet. I'm not sure at this point what it's asking for. It's just sending us this packet. So at this point, I mean, I can go into the reversing, which I tried for a little bit, or I can start looking at external resources. Obviously, Google is your friend. Other online games, we found one game, Pro Evolution Soccer, that was released, I think, like 6 months after Metal Gear Online 1. So I was able to boot that up, and another guy had already built a private server for the PC version of this game. So I was able to boot that up. It didn't have the packet, so it wasn't too helpful. But we were able to get some ideas from that. And the Metal Gear Online 2, by this point we had a packet capture from that one. We actually found this packet in there, which led to the next area. The client, or that packet, if you're wondering, was IP information. It was asking for the actual IP import to connect to, since the game takes place over peer-to-peer UDP stuff. So the game would try, or the client would try and connect to this host now, and we've actually got a connection going on. We'd see these UDP packets coming into the host, so it's all looking good. And the host would unexpectedly send this yet another packet, and neither the Pro Evolution Soccer or anything else actually had this packet in it. So we were kind of left with, what's it asking for now? It's already connecting, it already sees that. But what the payload was just the player ID. There are no error messages coming up because this is coming from the host, and it was the client actually making the action. So we start looking through and we find exactly where it makes that check, where it makes that jump, or the branch. You start following that through, you find another function call, and it makes a lot of calls, but I realized I never ended up checking any return values. It just called out a bunch of things and only read 4 bytes, kind of hard-coded out from that packet. So you start looking at things. Long story short, it just wanted you to echo back what it was sent, the player ID. It just had to be sent right back, alongside of a success code, which gave us basically the first game in, I think it was about 6 years after the game shut down. We were finally able to actually play a game. again and get back online. So of course, once you're kind of online, the question is, what do you do next? Well, I haven't been too involved in this part, but we have another guy on the team, our crazy Mexican, who has been trying to debug, or not debug, reverse engineer all the file formats being used, as they're not just your standard formats, figuring out where things are being plotted. And this is in this case, he's figuring out one of the maps. And he's gone on to adding kind of a custom map in there on the PS3, not the PS2. The PS3 you were able to patch a little bit easier. So just in conclusion, I mean, I've shown a few commands here, but we basically did this over about 10 months for each game. So 10 months for the first online game, 10 months for the other online game. And I've shown these very few commands, but we had to deal with about 80 different commands and do this over and over and figure out everything from that. There are a lot of frustrations, headaches, and there wasn't a lot of existing reference material, which is kind of why we want to give this presentation as something that could be referenced. It's been done before. It's not necessarily new, but there's no real material on this. And the other thing is, if you try this yourself, people are pretty crazy. We had a lot of trolls, a lot of people complaining that we're not working fast enough, we're not releasing things soon enough. I had one guy threatening legal action, saying that he was talking to Konami already, and that the lawyers were going to be, doing whatever lawyers do. So yeah, people are crazy, especially when you start getting in the video game community. The other thing is copyrights. Since we're running this server in the US, we have to be concerned about DMCA, the Digital Millennium Copyright Act, I think. In our case, the DMCA has an explicit exception for basically doing exactly this, building something that would interoperate with the client. As long as you don't violate the terms of service. In our case, the terms of service, they were already offline, and when you connect to our server, we control the terms of service, so we didn't violate our own terms. And I'm here. I usually present with one other guy, Joseph Tartaro. He's on the last slide. But there were other people that helped out with this project. Derek was involved pretty much from the start and kept me motivated to kind of keep working on this through some of the frustrations. Zach did another PS2 game, Resident Evil Outbreak, I believe it was. He kind of helped us with some of the groundbreaking, some of the early movement on this. Halston, he did the Pro Evolution Soccer server, which at one point I was basically sending him tweets. Didn't know the guy, just randomly sent him some tweets. I'm like, hey, you did this. Is this true on the protocol or not? And I was able to bounce a few ideas off him and figure things out. What the fuck are you thinking? And our kind of map and editor type stuff. I did a lot of work on the PS3 for that. Get a copy of the slides, some useful tools. And with a few minutes here, if there are any questions.
How much work was actually manual and how much was automated?
Can you hear me? Yeah. How much was manual and how much was actually implementation and functions and automated procedures? In terms of analysis, you said at some point it was a lot of, I don't know.
Pretty much everything in terms of the analysis was done manually. I think that a few times, grepping through, if you want to call that automated, grep was automated, but for the most part, it was all done manually. This is also very much a learning experience for all of us involved. Didn't have a lot of experience here, so we maybe did things the hard way, didn't know what tools existed. I think there was another question.
Around here?
Oh,
Question?
I'll repeat it. We tried. They were aware of the project. The question was, did we communicate with Konami before we did this project? And they were aware of our existence. There were some emails sent out, but we never really had their permission. Although, just judging from experience, Kojima, one of kind of the main people there, has expressed his support of kind of these fan-built, fan-done, not really servers. We were the first to do that, but think there's like a movie made by fans, and he'd express his support for that, different parodies, things like that. So we felt like we were probably on pretty good ground that they weren't going to try and do much against us, since it would just be bad publicity. We also end up spending a lot of time just making sure we're not doing donations. We have nothing for them to go for, just bad publicity. We made mention, we just kind of moved on with it. Like I said, DMCA, the question was just what about DMCA in terms of informing them. In our case, the terms of service didn't disallow it. They weren't responding to us. We just moved forward. All right, that's 30 minutes.
What tools did you use except packet tracing for reverse engineering?
Used IDA for one, was one of the tools we used. I had the pro version. I think a couple of the other guys were using version 5, I think, which is the free one. Actually, no, I guess we all must have been on the professional version, since that's the only one that supports MIPS. There's another one, Insight, I think it was. It was just basically a hex viewer. There weren't too many tools really that we used for that. There's a kernel patch on the PS2 also that we used that gave us a little bit of debugging access. Other than that, I mean, it was a lot of manual work. All right. Thank you very much.
Thank you so much.